Hello everyone and welcome to this new episode of our Deeptalk series where we invite a deep tech startup to present their business and explore their technology with an expert in the field. The goal is to better understand the fabric of a deep tech startup, their characteristics, the challenges that they face, and the great entrepreneurs behind the ideas. This series is brought to you by Bpifrance deep tech team and our late-stage investment fund, Large Venture, to promote the emergence of French champions in the digital, biotech, and of course, deep tech sectors. In this second episode, we are pleased to welcome Clément Delong, CEO of HuggingFace, and Antoine Borde, Director of FAIR, Facebook Artificial Intelligence Research Lab, with a focus on natural language processing. Gentlemen, good afternoon, and thank you for being with us.
Hi, everyone.
Natural language processing, or NLP, is currently generating a lot of buzz. It is driven by a very dynamic research environment, particularly in France, and the world's leading tech players and specialist startups are pushing the limits of what's possible at an unprecedented speed. Where do we exactly stand today? What is the future of NLP? That's what we'll try to figure out in this Deep Talk number 2. Now let's start with two pitches. First, the main concept of NLP by Antoine, and Clément will present his company, HuggingFace.
Okay. So the first slide on supervised learning, just to give in 20 seconds, all the success of AI we've seen for the last 10 to 20 years is based on what's called supervised learning, which means that you're showing examples to a machine of what it's supposed to accomplish. And you talk about labeled example in the sense that you're actually showing an example of what the machine is really supposed to do. In this example, very famous, it's about recognizing a handwritten digit, and to train the machines, you are showing pictures of digits in black and white here, and you are also telling the machine what digit each picture is corresponding to. Yeah. So the problem now that we are facing, particularly in NLP, is that it's getting very, very difficult and very tricky to get enough labeled example. I just show you one example here, which was actually the slide before, but that's fine. It's in terms of what we call multilingual NLP right now. So if you want to work in NLP, if you work in English, you can actually find a lot of labeled data. But as long as you're going to move to other languages, then it's going to be very hard to get enough labeled data in all these languages. And on Facebook, you have more than 200 languages, and many, many languages are spoken by millions of people. So you cannot just ignore that. So this is one of the motivation that led to the current revolution of NLP, I could say, which is called pre-training or self-supervised pre-training. And here the idea is that can I train or pre-train a machine without actually showing it any labels? And so that's the slide you're seeing now. You're going to create tasks that are going to be that you can create automatically without any human labeling them. In this case, the task is very simple. It's called masked language modeling. The idea that you're going to take some sentences like the dog ran quickly across the grass to fetch the ball, and you're going to hide some of the words, and then you're going to ask a machine, which is represented here by these arrows, and you're going to ask the machine to try to find which word were hidden. And of course, it's very easy to set up because you just have to take some text, and you have a lot of text available everywhere, and you can actually create this kind of games of trying to guess what the word was hidden was. And if the machine is correct, you can actually give a signal to the machine to say that was a good answer. If it's incorrect, you can update the machine to tell it that it should correct this answer. If you do that a few times, it's very bad. If you do that billions or hundreds of billions of times, it can get very good. And so the model I was showing before is called BERT, and it was a revolution. And I guess Clément is going to talk about it more in the next section. But I just wanted to show you what we can do with this. So this is the video of something we announced yesterday. So it's very fresh. It's called M2M100. And it's the first machine translation model that can actually translate from 100 languages to 100 languages without going through English. Okay, traditionally, if you want to translate a lot of languages, you're going to translate them to English, and then you're going to translate back to English to the language you want to do, with the kind of pre-training which I showed before. If you do that at a very, very big scale with millions of examples, you can actually learn one model that can actually learn to translate in all these languages. And to do that, you're going to do this max language modeling I was talking about, but you're not going to do it only in English. you're going to do it in hundreds of languages, and you're going to ask the model to try to do this game in all the languages. And at the end, with much more sophistication that I'm not going to tell here, you can have a model that is able to translate all these languages, please. So pre-trained model, because I'm going very fast now, is that they can actually generate very fluent language. A lot of the NLP system you're seeing now that are generating language now are based on this, and they, especially in English, they can be very, very good. They can capture a lot of the knowledge in their parameters, and actually they are powering a lot of breakthrough now in NLP. And you can use them for almost anything related to language because they are agnostic to the task. They're just trained on text. And they're not trained for something specific. But a big issue right now, one of the biggest one, is that they hallucinate. So they can actually generate language that is actually generating facts, but this fact can be wrong because the knowledge is stored in the weights of a model and can be too compressed in the weights of the model. So that's why a big area of research right now to improve them is to add some encyclopedic or world knowledge to this model so that they can actually have more information about the world. So next slide. This is the purpose of the RAG, so Retrieval Augmented Generation model that we actually did in collaboration with HuggingFace, Clément's company. And then in this case, you're not going to give only text as input to the model, you're also going to give Wikipedia as input to the model. And the idea is that the model is going to be able to look through Wikipedia to find the most relevant article for the task it's supposed to do. The task in this case is about question generation. So you give an answer, in this case it was Hemingway, and you're going to ask the machine to play the game Jeopardy to generate the question that is the most, for which Hemingway could be the answer. To do that, the model is going to take Hemingway, look in Wikipedia, what are the articles that refer to Hemingway, and use Hemingway and the article to generate the question. The idea of this is that now this model can be much more sophisticated and much more accurate on the knowledge they use because they're actually relying on an actual knowledge source to generate. And they're going to pick different examples, different articles every time they need to generate something else. So I'm going to stop here because I don't want to be too long. And I'm going to hand it off to Clément, who's going to maybe illustrate that with great examples and demo.
We're going to start by giving a little bit of background about HuggingFace, about what we do. We've been described, luckily, as doing the most practically interesting NLP research and development anywhere. That's mostly coming from our DNA of being both a science and engineering team. It's illustrated by, for example, by our CTO, Julien Chaumont, who was at Polytechnique. It was really, really great at math and has done some science in the past, but also a lot of engineering. Myself, I've been in machine learning for almost 10 years now. I started with machine learning, but applied to computer vision at a French company called Deeptalks. That got acquired by Google. We have many PhDs in the team, including our chief scientist, Thomas, was a PhD and is now one of the most recognized people in the field. We've been lucky to have our research and engineering mentioned in more than 2,000 research papers in the past 2 years. In terms of startups, we raised a bit more than 20 million so far. Our last round was a 15 million Series A led by Lux Capital, DeepTech venture fund based in New York and San Francisco. We also raised from A Capital and DataWorks, mostly in the US. We also raised from French angels, namely the CEOs at Dataiku and Datadog that a lot of people might be aware of. But also the CEO of MongoDB or the first monetization person at Cloudera. And about HuggingFace, we're obsessed by natural language processing. We believe, as Antoine pointed to, that we're definitely at a new era for NLP, thanks to a couple of trends, thanks to better compute, large open text data set, And to us, the last missing piece to the puzzle was transformers, or the application of transfer learning to NLP, which basically in a simplistic way finally makes deep learning for NLP work. And that's what led to a fantastic improvement on all the science leaderboards. So here you have the glue benchmark, which is an aggregation of different tasks. And you see that the accuracy score on it went from 69 to 88 in just a matter of months. And what's super interesting here is that it crossed the human baseline. So I'm not saying that on all NLP tasks now you are able to do human level things, but the fact that you can surpass it even on a specific data set, on a specific task, on a specific evaluation, namely the glue benchmark, is pretty amazing. It shows that progressively, when it comes to technology, we're moving from a world where only humans could understand natural language, which is the world we've been living in forever, which is why in companies, if you think of it, you have a very big like customer support, communication, internal, external communication, sales departments, which if you think of them are departments that are doing natural language processing, right? Understanding text and outputting some text. We're moving from a world where only humans could do that to a world where algorithms too can classify, understand, and generate natural language. And at HuggingFace, we've been lucky to contribute to that evolution by building the new standard for NLP, which is called HuggingFace Transformers, which in a simplistic way is a repository of model, fast tokenizers, data sets, and metrics management, and training and inference scripts. And overall, a unified API in PyTorch and TensorFlow that allows companies to input any sort of text that they have in natural language and output any sort of classification, prediction, or text. And the thing to remember about HuggingFace Transformers is that it's state of the art, because all the best NLP researchers all over the world at the best NLP teams, including at Facebook, as Antoine mentioned, are contributing to the library and adding their models that are beating the state of the art almost in real time when they release them. It's easy to use both by researchers and machine learning engineers because it's also production ready. So even if the models are state of the art, we built the abstractions that allows any company to take advantage of them for their NLP features in production. It's been said to be the most impactful tool for current NLP. And it led to quite an unprecedented adoption of it. It's been one of the fastest growing open source technology ever, going from 0 to 35,000 GitHub stars in a little bit over 2 years, over 3 million installs, and more than 600 contributors so far. To give you kind of like an idea and put things in perspective, with open source technologies that you might be familiar with, Elastic, for example. Elastic is a big public company here in the US. Took them 42 months to reach 10,000 GitHub stars. Apache Spark, with Databricks, which is a huge company. It took them 26 months to get to 10,000 stars. PyTorch from Facebook, it took them 12 months. It took us just 8 months to reach 10,000 stars, leading to a lot of companies using us, both for research, as Antoine mentioned. For example, Facebook is using transformers, but also in production. Now we have thousands of companies that are using transformers in production. And I'm going to show you a little bit how these companies are using transformers in production now. The most popular and I think mainstream use of transformers today is autocomplete. So that's what you get, for example, in Gmail when you're writing an email and it's suggesting either a subject or suggesting the rest of your text. It's been the first major use case that have been promoted by Google with Gmail, but now it's getting everywhere. Maybe you've tried it on LinkedIn, auto replies, for example. The second use case is question answering. So Bing, for example, is using our technology to show you the first relevant results when you do a query. And the way they do that is by scrapping the first page of results and leveraging a downstream task that is called question answering, which is going to find in a document where is the answer to your question. And then they extract this answer and show it to you in the first box of results. Another very popular use case for companies is text classification. A good example here is Mondiaux, which is a UK neobank. For all the dozens of thousands of customer support emails that they receive every day, they're going to classify it according to the priorities, the sentiment, or the department to be able to route the customer support email to the relevant team. Another very popular one is information extraction. So you get a text and you want to extract information from this text. A good example is Chegg, which is a homework and notebook platform online. When they get documents, they are able, using our technology, to extract information from these documents. So here, for example, they extract the fact that Washington is obviously, in this context, a person and not a location. That's an interesting example because that's something that was extremely hard to do with the previous generation of models, which were more rule-based and which weren't really understanding the meaning of words and sentences. Also here, they're able to extract, for example, the date or the topic to create tags or create categories of documents. And the last use case, which is really like one of the mainstream ones too, is conversational AI or chatbots. For example, Square is using our technology to be able to answer questions from users like, when will my package arrive? So that's just a couple of examples of how companies are using our technology. I'll be able to show it in action a little bit after, but I want to stop here, take a minute to pause and get to the next phase.
Thank you, Clément. Thank you, Antoine, as well. So now it's time to focus on the tech, lift the hood a bit and see what's inside. I'll let Antoine give a grilling to Clément.
I'm going to do an ambitious demo and I'm going to try to train a language model live using this fantastic product by community contributor Boris Daima. Can you all see my screen with my browser right now?
Yes.
Perfect. So what I started to do in Collab is setting the environment. As you can see here. All right. All right, the environment is set up correctly now. So we'll have to pick Twitter handle. So if that works for everyone, let's take Antoine's Twitter account. All right, here you go.
Much less training data than Elon Musk, but we'll see what it does.
So what it is doing now is that it's going to go and download Antoine's tweets to form the dataset. So as you see, it retrieved 257 tweets from Antoine. I think we're going to keep only 54 tweets. Now, what we're starting is to fine-tune the neural network. What is important to understand here is that the power of transfer learning make it so that you can train really, really fast on a very small number of examples, because most of the learning has been done in pre-training, right? So in the first phase of training on a huge data set, the model has already learned kind of like language characteristics. And here you only fine-tuning the model with a couple of examples. So as you can see, it's already almost done. It has been trained really, really fast. And it's uploading the model to the HuggingFace hub. So let's wait. It's also logging the model in weights and biases, which is a very great way to track your experiments. So the neural network has been trained successfully. So now we can go on the HuggingFace model hub and hopefully find this model that has been trained. Here it is, Hugging Tweet Antoine board. So as the model has been just uploaded, it's taking a little bit of time for it to load in the model hub. In the meantime, let's think about the prompt we can use. Remember, it's been trained on Antoine's tweets, so maybe we can try machine learning is. All right, let's see now if it's been loaded.
Yeah, I don't tweet too much about my dreams, so that's a good call.
All right. So as you can see right away, just a few minutes before we started fine-tuning it, it's starting to give some good answer. Machine learning is a huge challenge, and the fundamental challenge for today's AI research is overcoming some of the best challenges to improve our knowledge. Today, we're launching the Global Inventories platform, bringing an ever more powerful AI engine to the net.
That's perfect, because I mostly use Twitter to promote the open sourcing we do. So it's just like, I'm really glad that we're open sourcing X, which is a tweet actually I made this morning for the massively multilingual translation we released yesterday. So this is really on point, right? This is amazing demo.
As you said, in a lot of different languages. So for example, here you can see all the different models that have been trained in so many different languages by the community. And as you said, it's not only different languages, but it's different frameworks, it's different tasks that you can find for these models. So for example, I can show you a simple token classification model that companies can use. For example, I use this one. It's not currently loaded, so we'll wait a little bit. But the task of token classification is to classify some of the tokens, but also the words in a sentence, depending on their nature. So, for example, here, let's wait a little bit. As you can see here, it's detecting that Wolfgang is a person and that he lives in Berlin, and Berlin is a location. There are a lot of different really cool tasks that are even more kind of like a state of the art. Mm-hmm. One that I wanted to show that is really cool, that has been contributed by Facebook with a model that is called BART, and that is trained on a data set from CNN, is a summarization model. Which I'm super excited about because I think it's opening fantastic opportunities for companies, especially the ones dealing with a lot of content. It's taking here, for example, Wikipedia article about the Eiffel Tower and generating like a short summary of it automatically.
And Clément, you're mentioning a lot of successes, but now you're looking at all the a lot of models as well. So do you see also some shortcomings? What would you say are the current limitations of the models?
There are a lot. You really have to adapt your use case to these limitations. I think the main one for me today is really full accuracy, meaning it's impossible with these models today to get to 100% accuracy. Mm-hmm. Right. So if you have a use case where it's impossible to do a mistake, it's going to be hard for you to make it work today. Mm-hmm.
You mean like really critical applications where any mistake, like when we talk about critical computing or this kind of thing, it's not yet ready for that.
Exactly. You have, for these use cases, you have to keep a human in the loop to be able to make sure it's not going to make a mistake that is too damaging for your final audience. I think another limitation that a lot of companies are working on, where we're making progress, especially, for example, with the RAG model that you talked about, which I can show a little bit about, by the way, is the ability to retrain really fast to basically be updated with current knowledge. For example, a lot of the models that have been trained that are in the model hub, because they require such large pre-training, they've been trained before COVID, for example. And that's a huge problem, because now if you ask these models like things that are related to COVID, they don't know about it. They haven't adapted, just because it's hard to do very large pre-training. I think RAG, for example, is going to the right direction by making it easier to retrain and integrate new knowledge into these models. In addition to doing something else that is pretty cool, which is giving much more, I think, explainability and make it easier for everyone to understand why the model is answering that way, really pushing the explainability forward. So, for example, I can give an example. This demo is doing question answering and question generation. So, like Jeopardy style, you're giving it like a word, and it's going to generate a question for it. So, for example, I can do a free input here and do Statue of Liberty, for example. And as you can see, the model is generating a question about this monument, which are pretty good ones. But what's super interesting, I think, about these models is that it's generating the question from different documents. It's not retrieving a sentence from one specific document, but generating a completely new sentence based on several documents. So as you can see here, it's pulling from the article from Wikipedia, Statue of Liberty, Liberty Island, conservation, restoration of the Statue of Liberty. And you can actually follow what document it drew from. So here, for example, you see that the beginning of the sentence is from the Article 1, Statue of Liberty. Landmarks is actually from the Article 3. And Bedloe's Island is from Article 2. So it's really cool to be able to see where it drew from and to see that the model actually completely recreated a question.
I think we are going to talk business, if you're happy. Both of you, both at Fair and at HuggingFace, have taken a very definitive stand on open sourcing everything that you do, or most of what you do. Could you tell us what advantages you see in that system, and especially in NLP?
In our lab, so Fair, the AI research lab of Facebook that was open 5 years ago, even 6 now. We've always been open sourcing, and for us the reason was very clear. And there were two reasons that were very clear. One is that when you do research, you need to share, you need to publish, you need to open source, you need to bring the community with you so that they can actually validate or invalidate or critique or contradict your research. That's really the basis of the scientific method. And so as a research lab, we want to follow the scientific method, and it's come with publishing papers and being able to allow reproducibility for the thing you do, and it goes with releasing the code. Actually, the latest example of that is the startup Paper with Code that some of you might know, which is a big proponent. Is actually gathering the papers and the code that allows to reproduce the experiment that goes with it. Paper with Code was actually acquired by Facebook last year, just with the intent of supporting this and allowing them to actually grow and push their agenda for reproducibility bigger. And actually announced a big partnership with Archive last week, which is going to make it very easy for papers to come with code. So that's the first one. The second one was also to just also help, and that's actually how we collaborate with HuggingFace with other actors. We also believe that the challenges of AI are so big, right? We talked about what works, we talked about the challenges and what's ahead of us, and we don't believe that just ourselves we can actually solve them, right? We're going to make one step, and so we need to actually address them collectively. And to address them collectively, the best option is really to share the code and with the most open license possible, so that others can build on it, use it, and maybe get back to us with actually an even better model. And actually what we did for RAG that was mentioned by Clément, which was a collaboration on the code and on the project with HuggingFace. And I'm sure that if we were not working with HuggingFace on it, I don't think that the project would have had the same impact and the same success.
Yeah, I won't repeat what Antoine said, but I totally agree with his points. For us as a deep tech startup, there are two ways of seeing things. The first one is to believe that your main competitive advantage is to build proprietary technology yourself in closed door. And just try to be better than others for a couple of weeks, a couple of months before other people can catch up. That's kind of the first approach that companies can take. I believe that actually the main competitive advantage of a startup is not the technology that they built at one point. It's more their ability to keep building technology faster than other people. And if you move to this mindset, to the fact that your main competitive advantage is to be able to build technology faster than others, I think open source is the best framework for that. because one, it puts you and create processes for you to keep innovating, keep building. Because once you build something, you release it, and then you have to focus on the next thing because you know that everyone can use it, copy it, and do the same thing. And second, it allows you to take advantage of the power of the community and have everyone in the field really contribute to your technology, making it better than what you could do by yourself. And it's especially important, I think, for startups, even more so than to Facebook, because if you think of it, we're 25 people at HuggingFace, right? But what I used to say, what I'm always saying is that we're not actually 25 people, we're 600 contributors all over the world, from Facebook, from Google, from Microsoft, contributing to our technology and enabling us to always keep moving faster and faster on technology. So that's why we're taking this open source approach. It's the best way for us to always build technology faster than other people.
I'm wondering whether the partnership that startups like HuggingFace have with big tech companies working on NLP, Google, Microsoft, Facebook, whether these partnerships are balanced. You know, all the big corporates, they might pose a systemic risk. And one wonders if the open source collaboration with these companies are really balanced and sustainable.
That's a good question. Maybe I can take that. I think they are, because we are very different. You know, like Facebook and HuggingFace, we managed to collaborate, I think, well, because we're really, really different and we can take advantage of each other's strengths. And we usually don't compete so much on exactly the same thing because we're so different too. A good example is for us, we are able, for example, to move really, really fast from science to production because we don't have as many constraints as larger organizations. But also we don't have, for example, the resources in terms of like a compute, in terms of ability to train very large models than, for example, Facebook or other organizations have. So if you put these like pieces together, it creates a very powerful organization and a very powerful partnership. At least that's what we've seen for the moment.
Yeah, I mean, I agree. I mean, just one word, Laurent. I agree. I think we're complementary, and we also have a lot of examples, actually, people coming and going in between the different worlds, right? So our VP of AI right now, Jerome Pesati, used to be an entrepreneur in state startups. We have people actually who went from FAIR and now actually are working at HuggingFace. Nabla, who's one of the very promising startups in France as well, has been created by former FAIR people in Paris. And we're very happy about that. So there are always this kind of circle. And when we say playing with the community, is also to try to say to play along, right? We want to have the best people, but when they also want to chase for other goals in terms of flexibility, reactivity, also, of course, we encourage them to go and we support them as well through the open source that we do.
And I think that's even more true in the open source world. I think it might be a bit complicated, a bit more difficult when you're not open source. But for open source, you already have methodologies for it to work. You know, like when we're working with FAIR, and we like their contributions are very clear. You know, like either in terms of like a pull request, in terms of like model uploading, and our contribution is very clear too. But I think the open source world and the science world make it really easy to have these kind of collaborations. Might not be the case on every single domain, and depending on how the DeepTech startup is, what the DeepTech startup is focused on.
Perfect. Super. Thanks a lot, Antoine and Clément. Clément, maybe just a few words on the commercialization, the monetization of your product, your business, especially in the open source context, and then we'll go to questions.
Yeah. So we're not generating a lot of revenue right now. We haven't really focused on that. What we've believed from day one is that first you needed to get adoption. You needed to get like validation on the technology before focusing on how you can monetize that. We've been lucky to raise with investors who agree with this vision of investing in the open source, in the technology, before you try to monetize and generate revenue streams. We've started to experiment with some things, like, for example, we're providing to companies a way to run any of the 4,000 models that you've seen in the Model Hub, and to run the inference for their NLP use case in their NLP workflow at scale and with really low latency. It's been historically hard for companies to do so because these models are super, super large and sometimes can take like a few seconds for latency. So we take advantage of our expertise in NLP in running these models at scale with thousands of companies to provide a very simple API endpoints for companies who don't have NLP researchers internally to still take advantage of the power of these models in production. So that's one of the things that we're starting to experiment with, and we'll keep like doing more in the coming weeks and coming months.
Perfect. Thanks a lot. So the first question comes from Paul. What would you recommend, Antoine, to your fellow researchers at CNRS? Join Facebook, stay at the lab, or build a startup?
There is a trajectory for everyone. So I would not do. I know that myself. I was very happy at CNRS, and I can also tell why. I know I'm not good to. I would not build a startup. I don't think I have what it takes, and I'm pretty clear on this. No, I would say that we're in a time where really fundamental research is done jointly by academia and by companies. It's pretty unique, right? It was not the case 10 or 15 years ago, where if you are moving from academia to industry, you are losing the ability to do research in a fundamental way. It's not really true. So, but there is also a balance, and we still need, of course, a strong academia to do also most of the fundamental research. So there's a balance, and we try to favor at FAIR also kind of flexibility, so people can come and go. We have visiting professor, we have people being part-time. And we have a lot of partnership with academia in form of grant or joint PhD student programs. So I would say it depends on everyone, but you're not. I would say the only advice I would say is that don't stay silo, right? I think you can change, you can evolve in your career, and keep this open.
Perfect. Next question is for Clément. Clément, what triggered the fact, it's also from Paul, what triggered the fact that you moved away from France to develop your company? And what would you recommend to the French government to keep talented startups on their territory? Do you feel like the fact that successful companies leave the country is an issue to be addressed?
So I was already in the US when I started HuggingFace, but my co-founder and HuggingFace CTO is based in Paris. So half the team is in New York and half the team is in Paris. And we're investing on both countries. So we don't really see ourselves as like a US company. We really see ourselves as like in between the two. So the reason why we've been also in the US in addition to France is just because I was there when we started, and then we've been lucky to attract really, really good investors in the US and to start having users in the US. So it didn't make sense to stop being there. And when it comes to how could France do more on the topic, I don't have all the answers. I don't do politics. I don't know if I'm the right example to take here. But I would say that on DeepTech, pushing more funding, because DeepTech takes time, it takes resources before you can monetize. which is something historically that has been a bit harder in France than in the US. So I would favor kind of like pushing the ecosystem, enabling more VCs to focus on deep tech, give people more time to build interesting technologies. That would be what I would focus on.
Perfect, thanks. Maybe two more questions and then we'll finish the event. One is asked by Arnaud on the environmental cost of training deep learning models. Example, there are 30,000 pounds versus 11,000, so 3 times more of CO2 that's being emitted by the training of an NLP state-of-the-art model versus what a human emits on average in 1 year. And if we talk about gigaparameters NLP models, that's even 10 times more. So Clément and Antoine, do you think we are solving the right problem here?
Yeah, I can start on this one. It's a great question. I would say, first of all, there is the cost of training the model. There is the cost of inference the model. So training a model, you do it once, right? So yes, we should strive to have most efficient models, but you do it just once. What's costing a lot, and I know that very well at Facebook because we're investing a lot in that, is serving the model. Right? When you have billions of queries on a model, you really want to make sure that the model, when it's training, the kind of example that Clément showed, that is doing that efficiently. Let's say that the training can be costly, but since you do it once and if you use the model for many, many use cases, and that's why actually having one model with also many use cases and many languages is for us a way also to concentrate because you train only one and you serve so many use cases. So we should really differentiate the training and the usage. A lot of the cost comes in the usage. The second aspect is that we're investing a lot in also having smaller models. I guess in research, you have usually to train, and NLP is no different. First, you push the limit, and you push the limited scale in computing data to see how high can we go, right? That's the first curve, and that's what we are with Transformer, bigger and bigger. But just following along, and maybe you don't see that much, but days, and there are some in Transformer library, you have, okay, I know that I can go that high. Can I go that high? We like half the compute, 10 times less compute. 100 times less compute, right? And that's actually following it very closely. And so I'm actually confident that, and people are conscious of that. So we should not focus too much on the biggest model. They are more like a point on the curve, but the one who are actually going to be used in practice will be actually much smaller because of environmental cost, because of infrastructure cost, etc. So there are two curves. But I would like people to remember that there are two curves.
Yeah, I agree with that. I think a lot of organizations, including Fait and the HuggingFace, have been investing in reducing the size and the environmental cost of these models. For example, we've pioneered distillation with a model that is called DistillBERT, which is a distilled version of BERT, which in the HuggingFace Transformers library is now more used than the BERT model. We've also released a few months ago a paper on movement pruning, which is a new technique for pruning that we think is really inspiring, and we've been working with hardware providers to be able to enable that at scale and reduce the cost. We've been also working a lot on initiatives to promote these practices more. So, for example, we're co-organizing, I think, with some people, Angela Fan, I think, from Fait, something called Sustain NLP, which is an event to promote more sustainability focus in NLP. I think we're making progress. We have to keep working on it, but I think we're making progress.
Excellent. Very good. Last question with a bit of a positive touch at the end. It's related to the issue of reporting bias and not stating the obvious. Do you two think that it'll be possible in the future, near future, to teach a model a certain amount of common sense, meanings that are not captured from pure statistical perspective?
Yes, but when is the bigger question. I would say we're touching at the crux of what's very tricky. So I think there are two things in your question. The first is about the bias. They are now, and I think for many years now, and at Facebook, it's very important for us to really be conscious and to counterbalance the impact of the bias in data, because it's not like, is my data biased? Data is always biased, and some bias actually what you need the model to pick up, right? That's what they're training. Some are actually really completely really bad for the performance. And so now there is a lot of work to try to counterbalance that. So it's not like the model is able to consciously by itself counterbalance the bias, but the practitioner, the responsibility of people working in AI now and working in machine learning is that they're aware that they're biased and they're actually taking countermeasure when designing the model. So I would say the model is not maybe that smart, but the practitioner is smarter and should be counterbalancing that. The next stage would be when the model is smarter, and so the model itself is able to remove the bias in the data to actually come up with a performance that's unbiased. I agree with the question that it would come when the model has actually some common sense, and I would say also some values, because you can have common sense, but also how do you remove bias and to counterbalance that? It goes in terms of humanities and social sciences, right? It's not only a question of algorithmic or mathematics. There are research right there, and I would go actually, they go beyond NLP in this case. They go more in terms of the cognitive science aspect of things. How do humans learn? How do humans, and this is more where I would say the research is getting multimodal. And when you escape text and you will bring actions, you will bring maybe videos, you will bring 3D environment, you will bring like robotics, because I guess the main hypothesis right now, which might be wrong, this research, is that common sense comes from multimodality and the fact to actually having to merge these different modality in the same model, where is it maybe where common sense might emerge. So this is, I would say, I'm pretty sure we'll get there. I don't know when, but what is sure is that today, the practitioner must be responsible for the bias of their model and actually to remove it and to counterbalance that. And that's not in the future, that's today.
Yeah, I agree with that. And that's why, for example, for us in the models, we're pushing model cards, right, which are like explanations about the models. And we're pushing a section on biases, really for like people who are training new models to consciously state what the biases might be. I think what's important too is to do even more educations about what these models can do and can't do and how biased they are. And that's one of the reasons why, for example, at HuggingFace, we're doing so many demos, because we believe we should let the people try these models by themselves, test them, for them to be aware of the fact that they can be biased, they can be inaccurate, they can not work, and so they have to be careful with them. But sometimes also they can work and be a game changer for their use case.
Excellent, very wise word for the conclusion. And gentlemen, I'm afraid this is all we've got time for today. It was a pleasure having you for this deep talk. We can't wait to see what you have for us in the next few weeks and months. Thanks a lot to our audience, and see you next time.
Thank you.
Thanks, everyone.